All right, so we're going to start with number 8 here. How's that? Better? You guys are aware there's Chromebooks where you have your prompts open, or you're using your phones. Either one works, but Chromebook's a little bigger screen, I think, depending upon your phone. Because it was a joke. All right, so we got these 2 bowling balls, and they rest on a rack, and they're 0.77 meters apart. What is the force of gravity pulling each ball towards the other? All righty, let's do it. So that's number 8. What are some things I should have in my Y? Well, I don't know the weight of the bowling ball. Oh, is that the weight? Are kgs a unit of weight? No, what are they a unit of? Mass. So I don't know the weights. Remember, this is one of those big, you should go back and double check the book. This is one of the big things we talked about is the difference between mass and weight. Weight being a gravitational force, and mass being the amount of substance that is there, or the inert, and we use mass to then measure inertia also. So we don't know the weights. Okay, why is that important? What do we know about masses in the universe? Why? I agree they collide, but why do they collide? Oh, so they're attracted to each other? Oh. All mass is attracted to all other mass. What controls, what influences, what decides how strong that attraction is? You're right, the attraction we're talking about is called gravity. That's good, we've got a name. What determines how strong that gravitational attraction is to each other? The amount of mass. So what happens, let's say, if there's more mass, what does that say about the force? Stronger force, okay. What else influences how strong this force is? The distance, how does it influence it? Say it again. Closer than stronger force. Good. Yep. So I would say those are kind of the key points you'd want in your Y. You might even throw a diagram into your Y. You know, I did. I had the rack, I had a bowling ball and another bowling ball, and I marked that their centers were 0.77 meters. Do I want to keep that in meters? I heard yes, no, and maybe so. Yes, because meters are my base units. And then they have, let's see, 6.5 kilograms. Do I want to keep it in kilograms? Yes. And what was the other one? 7.9. And I even drew that there were 2 forces, and they were gravitational forces, like that. So that was my Y, those points, and then the drawing. Drawings are always kind of helpful. Let's see. Now I need an equation. I'm over here on the on the house side. So we're trying to find gravitational force. What do we think? Probably in forces and gravity. Good, good. I don't know what you mean. They're on the same site you go to read the book. Anybody? Which equation talks about gravitational force? Yeah. This one? That one, yep. That is our universal gravitational. That's the one you meant? Oh, that's got a constant, a big G in it. Maybe I better grab that for my equation sheet too. There it is. Oops. There we go. Oh, good. Let's see. I want to know the gravitational force. I know big G. I know M1. I know M2. I know R. Oh, cool. It's just arithmetic. Adding, subtracting, multiplying, dividing. Cool. So I'm looking for the gravitational force. That. Big G I just copied from my equation sheet. Newton meters squared per kilogram squared. Mass 1, 6.5 kilograms. Mass 2, 7.9 kilograms. R, 0.77 meters, and square it. All done. So go ahead and put that in your calculator. I'd use your numbers, that way you can check right away whether or not you got it right. I'll put my numbers in check. All right, so see if we get it right. I got it right. 5.78. Right. And minus they rounded it. I used 3. All right, on to number 7. Oh, 7 is very, very similar to 8. Almost like they're grouped together. So in 7, they tell us that there's a gravitational force between these two volleyball players. Would that be attractive or repulsive? We have 1 vote for repulsive and 1 vote for attractive. 2 for attractive. 3 for attractive. 3. 4. Who's 4? 4. So we're 1 for repulsive and 4 for attractive, and about 10 for where you don't want to be involved, don't bug us. And it is attractive, because all masses are attracted to every other mass in the universe. Yeah. Maybe we need volume to get it. Repetition, volume. Something. Wow, what I just said.
So our Y's would be the same thing?
Yeah. And then we're going to use the same equation. Only difference, if I can carry you away from talking about your English test, is And this one is what they tell you, right?
Yes.
They tell you this time,
Our G would still be the same, right?
yeah, because we're in the same universe. G is the universal gravitational constant. The only way to change it, go to a different universe. You need to find the edge. Well, either find the edge or the center of our universe first. I love it because I'm taping. I hope those that are playing around at home. Actually, I think we should do the well, no, we'll just put the numbers in. You can do the algebra afterwards, right? 69 and 79. It's broadcast right to your computer. No, it's fine. It's fine. Oh, look at that. Now it's just a little bit of algebra and some arithmetic, right?
Yes.
You can do it from there. Yeah. Do a little bit of algebra. Find out what r squared is. Then find out what r is, and then you're happy. Yeah. Because they told me what f was.
Why is it not SG like the last part? No, but he said that we were going to be rough. I realized it.
Is that what you were asking there?
Yes.
I just left it off. Huh? Sure. Yep. So algebra. Bring things up and down and all around. I would suggest bringing the r squared to the other side and bringing that 3.17 times 1097 back here. That's what I would suggest algebraically. So personally I would end up with r squared equals 6.67. Yeah, and then it's all arithmetic. All right. We are number 4 was requested.
Number 4.
Oh, this is like identical to that one we did as an example problem, isn't it? So, that's
Number 8.
huh? Yeah, we did this as an example problem. That's fine. You don't recall? Okay, I bet there are some people that don't recall. Very good. But I mean, they changed up the wording a little bit. They called this a necklace. We called ours a jade. I understand that. That can be confusing. All right. So let's see. If I remember correctly, we did a diagram before. And so they told us the center of mass moved over 7 centimeters. So I'm going to convert that to meters right away. That is meters. I converted from centimeters to meters right away so I wouldn't forget. Okay. And of course, we know that the whole stick is 1 meter long. And then, of course, this would be at 0.5 meters. What else did I tell? Well, where the center of mass of the meter stick is, should be halfway along the meter stick. Right? And they tell us the necklace is 86 grams. Should we keep that in grams? Right, especially look what they want our answer in. Kilograms. So 86 grams. So mass of the necklace, 0.086 kilograms. So the only thing we don't have on our diagram, because we have the objects, we have masses that we know. We don't know the mass of the meter stick. Where do you guys want to put, excuse me, our reference point? Remember, we can put it anywhere we want. We could, if we put it at the necklace, then there'd be 1 less mass of the necklace in our equation, because we'd have a 0 distance from the necklace. But we know the mass of the necklace, so I'm not worried about having too many of those in the equation. What don't we know the mass of? The meter stick. So what if we put our reference point where the center of mass of the meter stick is? That way, we put it someplace where there's something we don't know. So that's where we'll put our reference point A. And that's where all of our lengths are measured from. So let's grab our equation. We need the first page of this. Here we go. All right. So let's see. From point A, how far away is the center of mass of everything? Huh? I just didn't hear, sorry. Oh, does everyone understand where, on the diagram, where the center of mass of everything is located? The circle with the X. Santos, do you get that? Where is the center of mass of everything located in our diagram? What symbol did we use? The circle with the X that's in red? Yeah, okay. So the question is, do we know how far that is away from our reference point? What color is our reference point? Green. Sorry for those that are colorblind. I know. You see the green thing? Okay, I didn't know if you were colorblind. Well, this equation works for any amount of objects that you have. So if you have just 2 objects, it would work. The ... means put in as many terms as you want until you reach n, which would be the number of objects you had. So if we were doing this like, say we had a pallet of soup cans, of like 1,000 soup cans, and we wanted to figure out the center of mass of it. We'd use the same equation, we just have 1,000 terms. And it would just get brutal mathematically. All right, so that's what the ... means. Go on until you have as many as you need. Yeah, kind of like etc. So how, and that's a good question. How many objects do we have in this system? Two, right? What are they? The stick and the chain. Is that right? The meter stick and the chain. So, how XCM is how far the center of mass is from our point of reference. 0.077 meters. Does everyone agree? Now you'll have different numbers, right? So for XCM, I'm putting in 0.077 meters. Which object do you want to call object number 1? The necklace? Okay. Is everyone okay with the meter stick being number 1? Okay. So do we know the mass of the meter stick? No. So we're going to put in M sub M. Right? How far away is the center of mass of the meter stick from point A? 0 meters. And then the second object would be our necklace. Its mass, 0.086 kilograms. How far is its center mass from point A? I heard someone. 0.5 meters? Because A is in the center of the meter stick. It's on the end. And then we total up our masses, which is mm plus 0.086 kilograms. Oh, what's 0 times something? 0. Oh, so this gets simpler, right? Uh-oh, that dreaded algebra. What's my next algebraic step? Or arithmetic step? Or what? Yep. Do I have to take the 0.086 with me?
Yes, because they're
Because they're at the bottom of the fraction. I gotta take them with me. Give it a try. Tell me what you come up with for a mass. I'll give it a try. I'll tell you what I come up with